Okay, continue with chapter 6 today on functions. This is 6.3, which is the algebra of functions. So we can add and subtract functions, and so if f and g are two functions of x, then the sum f plus g is given by the f plus g of x, or we can simplify that into f of x plus g of x. Just take the actual functions f of x plus the function g of x, and we can add those together and we'll get the f plus g of x. Now the difference f minus g is also similar. We take f minus g of x, we just take the f of x minus our g of x, and we can take those two functions and subtract them, and we will get our difference. Now x is in the domain of f and g, and so that's kind of a key. And like I said here, basically, if we add two functions, we add their outputs, and to subtract two functions, subtract their outputs, and their outputs being the f of x and g of x. So, if we plug in x, the output is f of x, plug in x here, the output is g of x. We can also do something called a composition of functions. Now here order matters, so you really have to pay attention to what's being asked for, because if you do it in a different order, you're not going to get the same composition. And so again, we're going to let f and g be functions of x. And then it says, if f is composed of g, then we have the following. Now this special symbol here, the circle in between f and g, that's red, f of g, and then we have of x. We have a couple ofs in here, so f of g of x. And what that really is f of g of x. And so we're taking g of x and we're plugging that into f wherever x is in f. So we're taking the whole function of g of x and plugging it into the function f and then simplifying from there. So as I said, we say it's f of g of x, or sometimes it's called f is composed of g, but I'm going to go with the f of g of x if I ever say it out loud, and so that's what it's going to go. And we're going to substitute basically g of x into every x in f. So that's what we're doing. We're taking that whole output here and we're plugging that into the function f, and then we simplify. Okay, and so this gives us that the domain of g of x, whatever the domain here is, x, and then the domain of f now is going to be the whole g of x, because now x has become g of x. Now we can compose in different orders, and this is why I say it's very important to see what's being asked for, because this is f of g of x, so we plug in g of x into f, and so that's the first one. We can also do g of f of x, so we take f of x and plug it into g wherever there's x. We can do f of x, and so basically we take f of x, plug that into f for the x's, and we'll have a new function. And we can also do g of x, and so we take the whole function g of x, plug it into the original g function wherever there's an x, and then simplify from there. And we'll look at each one of these as we kind of go along. All right, so let's first start with adding and subtracting functions. So we're given the functions and we're supposed to indicate indicated operations. So we have g of a is equal to 3a plus 3, and f of a is equal to 2a minus 2. We're supposed to find g plus f of 9. Okay, well, remember, when we did this before, what we could do is we could say, well, that just becomes, instead of f plus g of 9, we could do f of 9 plus g of 9. And so that's what I'm going to rewrite it as. I'm going to say this is going to be g of 9 and then plus f of 9. Okay, and so I'm going to plug into 9 into g, 9 into f, simplify that, and then I'm going to add them together. So g of 9 is equal to 3 times 9 plus 3, which is equal to 27 plus 3, which is equal to 30. Now f of 9 is equal to 2 times 9 minus 2, which is 18 minus 2, which is 16. Now I want to take those two, g of 9, which we found was 30, f of 9, we found was 16. We add those together, we get 46. Okay? So that's what we get for the answer there. Now what about the next one? G of x equals x squared plus 2, and f of x is equal to 2x plus 5, and we want to find g minus f of 0. Well, again, what we can do is we can simplify this and say, okay, well, we want to find g of 0 minus f of 0. So now what we have to do is go find those. So g of 0 is equal to 0 squared plus 2, which is equal to 2. And f of 0 is equal to 2 times 0 plus 5, which is equal to 5. So up here, g of 0, well, that was 2. Oops, not plus, minus, sorry. And so minus, and now f of 0 was 5, and 2 minus 5 is a negative 3. And so that's pretty much how simple it can be. Now they could have also said plug in, maybe some other variable or some fraction, and all you do is you plug it in, simplify both of them, and then in this case we added them, and then in this case we subtracted them. So let's do some more. So these are cases where we're adding different things instead of numbers. So now we're taking this one and we're plugging in a. So what we want to do is find f of a plus g of a. Well, f of a is equal to negative 2a minus 4. G of a is a squared plus 3. So we just plug those in there. So let's give us a little more room since there are expressions here. So we'll have f of a is minus 2a minus 4. And then g of a is plus a squared plus 3. Now we just have to simplify. Well, I'm going to write it in decreasing order of powers. So the highest power is a squared. So I'm going to say a squared. Then the next day is this one, minus 2a. And then I've got like terms. That's the only like term for this whole thing. Minus 4 plus 3 is minus 1. And then that then would be my solution to f plus g of a. And again, that simplifies the f of a plus g of a, which they gave us. All right, what about this next one? Well, we have f of n is equal to negative 3n squared plus 1, and g of n is equal to 2n plus 1. We only want to find f minus g of n over 3. So what does that want us to do? Well, that wants us to find f of n over 3 minus g of n over 3. Okay, easy enough. So what we're going to do is we're going to plug in f of n over 3 and simplify. So that's a minus 3 times n is going to be n over 3 squared plus 1. And so that's going to be a minus 3, and that's going to give us n squared over 9, because we're going to square the n, and we're going to square the 3 plus 1. And so now we can reduce that. 3 goes in here 3 times, so we have a minus n squared over 3 plus 1. Okay, so that gives us the first piece. Now the second piece, d of n over 3 is equal to 2 times n over 3 plus 1. Well, this one's a little simpler. That's just 2n over 3 plus 1. Now it tells us subtract them. So we're going to take our first one, minus n squared over 3 plus 1, and that is going to be, let's put it in parentheses, minus our second one, which is 2n over 3 plus 1. So now we can drop the parentheses on the first one, minus n squared over 3 plus 1. Now we distribute that negative, so that's going to be minus 2n over 3, then minus 1. Well, guess what? Plus 1, minus 1 cancel. Now we have two fractions. They have a common denominator. So let's put them together. So minus n squared minus 2n all over 3. And so now we've simplified the f minus g of n over 3 into the simple fraction negative n squared minus 2n over 3. Okay. All right, so the next one, instead of writing it out f minus g of n over 2, they wrote it out how we ended up actually doing it. We broke it down to f of, the previous one, we did it to the n over 3 minus g of n over 3 when it was given like that, and they're giving it to us like that already. So all we have to do is plug in n over 2 in each of those and simplify. So that's going to be 3 times n over 2 plus 4. That's going to be 3n over 2 plus 4. And here, g of n over 2 is going to be n over 2 cubed minus 5 times n over 2. All right, well, n to the third is n to the third. 2 to the third is 2 times 4 times 2 more is 8, so that's going to be 8. And now we have minus 5n over 2. All right, now it says subtract. Take the first minus the second. Okay, well, that gives us, the first is 3n over 2 plus 4, that whole thing, minus, now let's put the second one in parentheses because it's going to be a little different because we're going to have to distribute that negative sign. So we'll take a minus times that and a minus times that. And so we get 3n over 2 plus 4 minus n to the third over 8. And then a minus times a minus is plus. And we have 5n over 2. All right. Here we have two terms that have the same denominator. We could simplify. So let's have a negative n to the third over 8 plus, now we have 3n plus 5n, so it's going to be 8n all over 2 plus 4. Now, this could be our final answer. They didn't tell us what they needed, but we can get a common denominator here fairly simple. We can multiply the second one times 4 over 4, and we get 8. And this one we can multiply by 8 over 8 and have an 8 in the denominator. And if we do that, that's going to give us a negative n to the third. And this is going to be plus 32n. And that's going to be plus 32 all over 8. So we've just simplified, we multiplied, these two together, and we multiplied those two together. Our denominators are all 8, and then we just added them all together, and we got our final answer there as one fraction, and that's in the most simple form as possible. All right, what about the next one? Well, the next one basically is telling us plug in negative 6 into g and h. All right, so if we do that, g of negative 6 is equal to, well, negative 6 squared minus 2. Well, negative 6, the quantity squared is going to be 36, and we have minus 2. That's going to be 34. Now, h of a negative 6, well, what is that going to be? Well, that's going to be 2 times negative 6 plus 5. That's going to be a minus 12 plus 5, which is going to be a minus 7. And now they want us to take and add the two together. So we're going to take 34 minus 7, basically. And that should be 27. Okay. And then that's going to be our final answer. So in that case, we plugged in values for all the variables, and we ended up with the actual number. Instead of like here, we plugged in new variables into the thing, and we got variables in our final answer. All right, so those are the adding and subtracting. So now we're going to do composition. And again, composition, it just depends on what they tell us to do on how we do it. So they give us g of x is negative x plus 5, and they give us f of x minus 3. And they want us to find g of f of x. Well, remember, we can rewrite this as g of f of x, just like that. And so we can rewrite this into this form, and that tells us we're going to plug in f of x into g in place of the x. So we're taking basically this piece here, and we're going to replace all the x's in our original g of x. So f of x is minus 2x minus 3, and then plus 5. Now we simplify, distribute across. That's going to be a minus 2x plus 3 and plus 5. Well, there's only like here and here, so we have a minus 2x plus 8. And so that's what g of f of x is equal to negative 2x plus 8. Okay. Now this one, instead of having two different functions, we have the same function and we're plugging it back into itself. So what this one really is saying is take g of g of negative 3. And what does that look like? Well, it's g of negative 3. And so what we need to do is find what g of negative 3 is, and then plug that into the original g here. So g of negative 3, well, what does that equal? Well, we have negative 3 squared then plus 3. Well, negative 3, the quantity squared, 3 squared is going to be 9 plus 3. And so that's going to give us 12. So that's g of negative 3 is 12. So we're going to put that into our g here for a. So that's going to be g of negative 3 equals, and we'll have a 12 squared plus 3. And 12 squared is 144 plus 3. And so that's going to be 147. Okay. So in this one, the key thing is we had to first find out what g of negative 3 was, which we did over here. We got the 12. And then we could plug in that into our original g of a here. And 12 squared plus 3 is the 147. All right. So here we got g of a is 2a plus 4, and h of a is 4a plus 5. We want to find h of g of 2. Well, what does that mean? We want to find h of g of 2. So we need to find what g of 2 is. Okay? Well, g of 2 is 2 times 2 plus 4. Well, 2 times 2 is 4 plus 4 is 8. Okay? So that was pretty easy. So now what do? Well, now we plug that into here because we want to have h of g of 2. And so we're plugging g of 2, which we said was 8, into the h. So we have 4 times 8 plus 5. So it's 32 plus 5, and that's 37. Okay. So again, because they gave us a number, we actually plugged it in and we got a value out there as far as what it was equal to. All right. So let's move on to the next one here. G of x is 3x plus 4, and h of x is x cubed plus 3x. And we want to find g of h of 3. So we want g of h of 3. Okay. So what are we going to do? Well, we have to first find what h of 3 is. And so what is that? Okay, well, h of 3, here's h. So we're going to have h of 3. That's going to be 3 cubed plus 3 times 3. Well, 3 times 3 is 9 times 3 is 27, plus 3 times 3 is 9. And that's going to give us 36. Okay. So that looks good so far. And so now what do? Well, now what we have to do is we have to plug that into what g is. And so now we're going to say, okay, well, g of h of 3 is equal to 3 times, well, we just found h of 3 was 36, so 36 plus 4. Well, now we need to take 36 times 3. Well, 36 times 3, that's 18. That's 9108 plus 4. And so it's going to be 112. So that's what g of 8 of 3 is equal to 112. And again, it's one of those things we just had to find our first value, h of 3, plug that into the other function, and we get out an actual numerical value like we did here. And that's all I have for this section. The key thing with these are, we could play with all kinds of different values for the, variable here. We could plug in, x or y or z or whatever into it and simplify, but it's the same concept. You just have to do each of the functions in turn and in the correct order. So, when you do this, we could have said, well, instead of 2, maybe we wanted to plug in x squared. Well, then you would first find g of x squared, and you'd work that out, find it, and then you plug that in to h, and so wherever there was an x, you plug in the value you got here when you plugged in x squared for g. And so it's just a thing of working your way through the problems and simplifying and getting your final.